Displacement versus Distance by Soumya, Ariani, and McKenna. Definition of displacement. Displacement is the difference between ending and starting positions. In other words, displacement is the integral of velocity.
The formula for displacement is the integral from a to b of the velocity function, also v of t dt.
Displacement example. Find the displacement of a particle with velocity given by the function 6 sine of 3t on the time interval from 0 to pi over 2.
So to solve this problem, the first thing you need to do is draw a graph. So you're going to draw your graph of 6 sine of 3t and then label your bounds 0 and pi over 2, so you can see that you're finding the area under the curve. Your second step is to write your displacement formula, which we gave to you previously is the integral from a to b of v of t dt. Your third step is to plug in what you have and solve. So you know your bounds are 0 and pi over 2, and you know that your velocity function is 6 sine of 3t. After you integrate, you get negative 2 cosine of 3t, and then you evaluate that at your bounds pi over 2 and 0 to get your final answer of 2.
Definition of distance. Distance refers to total distance, which is how far an object traveled regardless of direction.
The formula for distance is the integral from a to b of your speed, or the integral from a to b of the absolute value of your velocity.
Distance example. Find the total distance of a particle with velocity given by the equation negative 3t squared plus 16 on the interval 0 to 1.
To solve this problem, the first thing you need to do is draw a rough sketch. So you have the equation negative 3t squared plus 16, which is a basic parabola, except it's flipped and shifted up 16. Your second step is to write your distance formula. So your distance formula is the integral from a to b of the absolute value of your velocity. And your third step is to plug in what you have and solve. In this case, when you plug in your bounds and your velocity function is negative, so the absolute value makes your function positive. So essentially, you're integrating 0 to 1 of 3t squared plus 12 dt. After you integrate and you plug in your bounds, you get 13.
Practice problems. Find the total distance and displacement of the particle with position given by the equation e to the power of 3t on the interval 0 to 5.
Your first step to solve this problem is to recognize that you were given position and you need velocity. So you're going to take the derivative of position with respect to time to find your velocity. So d dt of e to the 3t is going to be 3e to the 3t. Your second step is to find distance. So the distance formula is the integral from a to b of your absolute value of your velocity. So when you plug in, you get 0 to 5 of the absolute value of 3e to the 3t. And you get, this is your answer. Your step 3 is to find displacement. Displacement is a similar formula to total distance, except there is no absolute value. So you're going to plug in and get the same answer. The reason that you get the same answer in both these cases is because your original function was not negative. And so after you integrate, you get the same answer.
Practice problems. A cat is walking through a neighborhood. His walk is modeled by the graph. What is the displacement from time t is equal to 0 to t is equal to 5? What is the total distance over the same interval?
So in this case, you were given a graph instead of a function, so you're going to solve it a different way. So here's your graph that you were given, which models the walk of a cat through a neighborhood. To find the total distance, you're going to evaluate the area between each sub-interval. So you're going to take the interval from 0 to 1, interval from 0 to 1 to 2, interval from 2 to 3, 3 to 4, and 4 to 5. And you're going to find the area under the curve of each of these intervals. So after you find the areas, you're going to add all the areas up, and you're going to find that the displacement and the total distance are 12. The reason that they both are the same is because this graph did not shift into the negative, so then the total distance did not change.